Hello everyone. So in this module we're gonna do trigonometry. So what is we are first reading the NCRT because when we understand things we don't have to put as much time into practice. When we understand something very thoroughly, we just have to use our own natural intelligence to um, understand the question, to break the question into its corresponding parts, and to solve it. So we'll be cutting on practice time, and we'll be increasing on understanding time. So that is our idea. So we'll begin with reading this chapter. So we'll start with angles
Angle triangle,
from here.
and study their properties. Properties. 3.2 Angles. Angle is a measure of rotation of a given ray about its initial point. The
So angle is a measure of rotation. So angle is what is a measure? It's a you know way of describing one thing. So angle is a measure of rotation. So it's a way of describing rotation. Like seconds is a way of describing time. Seconds tells us about time, right? Tells us about how much time it is. And also meter tells us about length. So it's a way of describing one property. Let's say you have pink eyes, so someone says that you have pink eyes, so that is a way of describing about you.
original rays. Chapter 3.
uh so the original ray is the initial side. This is the terminal side. The terminal always means final. If you've heard these words like terminal gate in railway stations and stuff like that, and yeah, even term 1, term 2, right? So term means something which is ending. So this is terminal side, which is the ending side, and this is the initial side, and this is the vertex. Vertex is the point of rotation. The point, this is O basically, the point through which it has rotated. And then if it if the rotation has happened anti-clockwise, it's positive. If the rotation has happened in clockwise manner, it is negative. You can remember this in this xy plane. I'll just show. So if we take the xy plane for example, so if this is the positive plane and this is the negative plane, so it works like that. So, and if we take this as the vertex, this is a very good way to remember. This is not something that you should use logically and everything. This is a good way to remember. This makes logic sense logically when we put it into understanding. But then it is a very good tool to remember. It's just that is right. So in the Cartesian plane, so the first quadrant is positive. This fourth quadrant the first quadrant is positive. The fourth quadrant is negative. So if it goes clockwise like this, it'll be negative. If it goes anti-clockwise like that, it'll be positive. So we learn this in the 10th chapter, that is statistics. No, that is straight line. Sorry, not statistics. So we were also making notes. First is the usage. So trigonometry is used in ships, building shadow, and other things like this. It has a lot of usage in these things. In ancient times, also people used it for like a lot of stuff like constellations and everything. Constellations, figuring out where they are, and also we also use it in the parallax method, which is related to physics. We learn about this in physics, the parallax method. So yes, all of this is connected, and we have angles. So what is it? What is initial? What is final? And stuff. We have all of that. We'll just pull this over and we make this. So yeah, let's study. So what they're telling in this paragraph is that if the terminal side and the initial side are the same, that means the ray is a full angle, is a complete angle. It's a 360 degree. But then we this can be a 360 degree angle can be one complete rotation can from the position of initial to the final can be a very good measurement of an angle, but only when wheels are moving, right? In wheels and all, in wheels of the bus go round and round, in all of those things we can use this measurement. But then in daily life, let's say it is 60 degree or 70 degree, how will we tell it's 60 or 70 degree? Or let's say it is this angle, how will we tell it's this angle? We'll tell this angle, we'll tell it's this angle, ma'am, it's this angle. Ma'am will hit you on your uh, uh, you know cheek one, she'll slap you, right? So what do? So you use measurements like degree and radian. So we learn more about degree and radian in the next unit, the next paragraph, that is. So degree measure is, let's listen to ncr let's listen to the ncrt, because the ncrt has the best explanation one could ever listen to. So, oh my god. So let's listen to this then.
If a rotation from the initial side to terminal side is f1 360 of a revolution, the angle is said to have a measure of 1 degree, written as 1 degree. A degree is divided into 60 minutes, and a minute is divided into 60 seconds.
So if a rotation from the initial or the to the terminal side is, so if one rotation, only one rotation, from here to one rotation, little bit is 1/360th of the revolution. So what they are saying is every 1/360th of the revolution is a rotation. It can be read ulta. But NCRT, they want to make us mad, no? So that is why they are writing like this, so that we pull our head out.
Seconds. 1/60th of a degree is called a minute, written as 1, and 1/60th of a minute is called a second.
1/60th minute is like written like this. 1/60th second. 1/60th thing, like 1/60th is one fraction. 1/60th second is a fraction. So 1 degree equals to 60 minutes. 1 minute equals to 60 seconds, basically. Why do we do this? So that we are able to get the most precise amount of data as we can, right? Why do we need very precise data? So that we can do calculations better.
Second, written as 1. Thus, 1 degree is equal to 60, 1 is equal to 60 sum of the angles whose measures are 360 degree 180 degree, 270 degrees, 420 degrees, 30 degrees, 420 degrees are shown.
So these are some of the measures. So this is 360 degree, this is 180, this is 270, 420. 420 is it came to the initial position and the final position met here, and then the final position again went up to again went up more, 30 60 degrees, right? So it is basically like this, and then minus is, it works clockwise. Plus is it works anti-clockwise. Yeah. When you don't understand anything in the NCRT, don't worry. There are enough repetition of concepts. Thus, that too in different languages. Like sometimes it's in a simpler language. Sometimes in a more difficult and complex and more precise language, I can say. So when you don't understand from the NCRT, don't worry. We'll surely get through it.
There is another unit for measurement of an angle, called the radian measure.
It is called
Angles.
the radian measure. So there are two measures, degree measure and radian measure. So let's make notes for the degree measure first. So we've made notes for angles. We'll make notes for degree measure too. These small notes will help us, check our understanding how much we know. So basically, it's just that. So we'll, you know, how many minutes in one this thing basically we'll have to ask. In how much is one rotation? How much is one rotation? These notes will be available to you. You have to just go on to remnotes.com, www.remnotes.com. And then we'll give you the login link and everything. You have to just go through that. How much is one rotation? It is 1 second. How much is one rotation? 136th. One 1 minute is 1/60th of a second. Second. 1 second is 1/60th of a min of a sorry, it is not 1/60th of a second, it is 1/60th of a rotation. Rotation 1/60th of a minute. Done. We are done, right? So we are done with the notes for degree measure. We just have three rem notes for this. We'll go on to radian measure. I'm so sorry about the noise outside. Actually, we are having, a death occurred in our, surroundings. So that is why it's very noisy. I'm so sorry about that. But surely it will get
Angle
over.
subtended at the center by an arc of length 1 unit in a unit circle. Circle.
So what they are telling is, there is another unit called the radian measure, an angle subtended at the center. So angle is subtended at the center. What is subtended? The vortex or the center of the angle is at the center of the circle. So angle is subtended at the center. The arc length, 1 unit in a unit circle. So basically the radius of the circle is 1 unit and the arc length of the circle is also 1 unit. We don't know which unit. It could be a centimeter, it could be meter. We don't know. Who cares? We just care about the radius and the arc length ka measure being the same, right? We just care about the length of the radius and the length of the arc length being the same. Yes, is said to have a measure of 1 radian. So there are more examples to this too. So in the figure 1 to 4, OA is like this. So it's basically like this. So in this figure, you will understand every single thing. So basically, this is the arc. So this is the angle. This blue color is the angle. Forget everything and just look at this circle. Forget everything in the world. Just look at this circle. So we have a circle. The center of the angle is same as the center of the circle. Center of the angle. the center of the circle are the same. So this radius is 1 unit, this radius is 1 unit, and this arc length is also 1 unit. So if the radius and the arc length are the same, that is 1 unit, same length, forget about it. If it was 2 unit also, if it was 3 unit also, if it was 4 unit also, it doesn't matter. But if the radius and the arc length are the same, then then this angle will be 1 radian. This angle will be of 1 radian. So what is a radian? What is basically a radian? It's said here also. 1 second. We'll read further. So a radian is basically okay, it's not given. So a radian is r by arc length by r. So a radian is arc length by radius. What is it? Arc length by radius equal to x amount of radians. So if arc length and radius are the same. So if let's make a circle. So we have a circle right here, and if the arc length, let's say the radius is even let's say the radius is 2 centimeters. This is also 2 centimeters, and this is also 2 centimeters. So arc length by radius is 2 centimeters, right? What do we get? We divide this, we get 1 1, so we get 1 rad. So you saw, right? It doesn't matter if 1 rad. Forgive my handwriting, it's really bad, but then it's 1 rad. So it doesn't matter if it's anything, it will always be 1 rad. So there is degree measure and then there is radian measure. These two work like that.
Radius 1 unit is 2 pi. Thus, one complete revolution of the initial side subtends an angle of 2 pi radian. More generally, in a circle of radius r, an arc of length r will subtend an angle of 1 radian. It is well known that equal arcs of a circle subtend equal angle at the center.
So what they are telling is the circumference of a circle of radius 1 unit is 2 pi. So the it's 2 pi r, but then yeah, NCRT made a printing mistake. So a circumference of a circle of radius 1 unit is 2 pi r. Right? You right? Yeah, but then it's 2 pi. Why? Because I'll show. Why is it 2 pi? 1 second. So we have 1 unit, right? Let's say 1 centimeter. Okay? 1 centimeter circle we have, right? What will be the circumference? So the formula is 2 pi r, but here it will be 2 pi. Why? Because 2 pi into 1 is equal to 2 pi, right? So it will be 2 pi here. So many people will have a confusion there. So so there it is kind of confusion. So we'll finish rad and then we'll end the module here because it'll become too long then. So it's basically so radians is basically when we do that arc length divided by radius. So it is L by R. So what they're telling is an arc length, let's say we have an arc length of L, right? So the measure of the angle will be L by R radian. That is it. That is it. That is it. So it'll be L by R. So the length, so the value of L, the value of length will be the measure of the radian into R, basically. So we'll make notes of this. So that was a pretty easy concept. We'll not have to make a lot of notes. We'll just have to uh, make this. What is arc length? We know that. And what is, if arc length is L and radius is R, then what is the value of L? What is the amount, the measure of L? Value of L. It is L. It is R into theta. Because why is it R into theta? Because theta is L by R. So L is R into theta. So here we have it, right? Even if it's 2 centimeter, even if this is 2 centimeters, if the radius is 2 centimeters and the arc length is 2 centimeters, it'll still be like this. It'll still be like this. 2 by 2 equals to 1 rad. 1 rad. Basically, it's that much. So we've understood rad. We've understood this one. So now we'll understand the relationship between radian and real numbers.
52 Mathematics. 3rd February 2003 Relation
Highway,
between radian and real numbers. Consider the unit circle with center O. Let A
So,
consider OA as initial.
so consider the unit circle with this thing O. Okay, 1 second. So what they're telling is you have to consider this one, this circle with center O. Basically, it's that. Let's understand.
Side of an angle. Then the length of an arc of the 3rd February 2003 Relation between radian and real numbers. Consider the unit circle with center O. Let A be any point on the circle. Consider OA as initial side of an angle. Then the length of
So OA is the initial side. OA is the initial side.
an arc of the circle will give the radian measure of the angle which the arc will subtend at the center of the circle.
So consider OA is the initial side. Then the length of the arc of the circle will give the radian measure. So let's say the length is 2. So the radian will be 2 radians. If the length is 1, so the radian will be 1 radian, right? Because the length of the circle is 1, as shown here. It's basically that much. So they are telling what is the relationship between radians and this one. Radians and real numbers. We are gonna understand the relationship. So the arc will the length of the arc will give the measure of the angle. Because through the length of the arc, we can easily find out the measure. How? By radians, right? By this degree called radians. So consider PAQ is a line. Yeah, let it read.
Circle. Consider the line PAQ which is tangent to the circle at A. Let the point A represent the real number 0, AP represents positive real number,
So basically, they are telling about this picture. You don't have to understand this. You have to just see this picture and understand this picture.
Number and AQ represents negative real numbers.
So this part is negative. This part is positive. That is it. That is it. They are telling. They'll use such big words, no, it'll make people go crazy.
Numbers. Fig 3.5. If we rope the line AP in the anticlockwise direction along the circle, and AQ in the clockwise direction, then every real number will correspond to a radian measure and conversely. Thus, radian measures and real numbers can be considered as one and the same.
So what we do is we take this line and we put it like this. We pull it like this. Here we pull it. We take this line and pull it like this. And let's say this is 1. The unit of this is 1 centimeter. And this is 1 centimeter. This is 1 centimeter. This is minus 1 centimeter. And this is minus 1 centimeter. So when we put it like this, when we rope it like this, so if this is the initial 1 second. बच्चे pretty. I wanna be that pretty. I'm so sorry, there was a technical glitch. So I hope you've skipped to the good part. So we'll get on to this. So we were studying how radians and real numbers are one and the same. So radians, is arc length divided by radius. So if the radius is 1, the arc length is 1. So if we rope this line onto this till here, so this will be 2, this will be 1. So um, that'll be 1 rad. So this will be 2 rad basically. So it works like that. And the relationship between degree and radians is similar, because when you see this, when we rope this here, when we rope onto this like this, so this will be 1, right? And this will be 2. So this will be 360 degrees. As you can see, this will be 360 degrees, and this will be this will be 180 degrees, and this will be 90 degrees. So 90 degrees is 1 rad. Sorry, 1 rad is 180 degrees. So when you have the same radiuses, it'll be 1 rad. So 1 rad is 90 degrees, and this and that is what most people think, right? But this is not the case. This is wrong. That is not the case. Most people would think like that, but this is not the case. This is what I wanted to clarify. This will not always be 90 degrees. This could be 160 degrees too, and this could be 2 rads, and this could be 1 rad. So it could be different for different radiuses and different uh arc lengths, but this thing will be same. The ratio will be the same. And will this be the case? Hmm. This might not be, because as you see here, 2 pi radians will always be 360 and pi radian will always be 180. How is that possible? If for different arc lengths and different radiuses, we have different radians, right? We have different radians. So how is, you know, 2 pi radian always, how is it 360? And how is pi radian always 180? Because our assumption is again not true. I want to address all of these wrong assumptions too. That is why I'm going slow with this part. Yes? So our assumption is again not true. So 1 radian will always be the same. 1 rad will always be the same across circles. Across circles. Same. Why is this? How is this possible? Because no matter, one second, no matter what the circle it is, no matter which circle it is, one second, let's remove all of this. No matter which circle it is, no matter which, uh, you know, one second, yeah, no matter which circle it is, it'll always, and what is the radius and what is the size, it will always have some if the arc length, because a radian is always a ratio. Radian is not only a measure, right? Radian is not a simple measure like degree. It is a ratio of, I'm taking this slow because it should be taken slow. It is a ratio of radius and arc length, right? It is a ratio of radius and arc length. Thus, it doesn't matter if this is 1, 2, 3, 4, or even 100. If the radius is 100, if this is also 100, so it will always be 1 rad. This will always be 1 rad. Yes? Why is this? Because 1 divided by 1 divided by 1 is 1, and 100 divided by 100 is also 1. 100 divided by 100 is also 1. So this is the idea behind this, right? So we'll write this in our understanding. This is an understanding that a lot of times we don't get, right? So let's write this in our understanding. Relationship between radians and real numbers. Radian numbers and real numbers can be considered one and the same, right? Why? Because if we draw a number line, they can be you know measured in a similar manner. Y can be considered considered one and the same, because they can be measured in a similar manner. Basically, that's it. So we've understood. And what is a radian? A radian is a ratio. Let's understand it in that perspective. A ratio of arc length and radius. Thus, L by R equals to X rads. It is basically that much. So we've understood. So radian is always a ratio. It's nothing more than a ratio. And what is the relationship between degree and radian? So this is the last thing of our understanding. After this we will go on to exercises, solving exercises from RD Sharma. So yes, what is the relationship between degree and radian? So as you know, one circle, how as you know one circle is 2 pi radians, right? 2 pi 2 pi r. The circumference is 2 pi r, right? Let's say this is the initial line. This is the initial line, and then initial ray, and then it comes back, and then our ray moves like this, like this, like this, and comes back like this, and this is our final ray. So it and our radius is r. So what will be the radians? It will be the ratio of our arc length. Our arc length is 2 pi r, and the radius is r. So r and r will get cut, and then our answer will be 2 pi. So 2 pi is what? 2 pi is, so it is basically the ratio of the arc length and the radius. So the arc length is circumference and the radius is this. It is basically, so we've gotten our answer, which is the measure of the rotation. The measure of the rotation is the 2 pi. So this can be also written as 360 degrees, right? How? Because this is a one complete rotation, like this. This is a complete rotation. So this can be also written as 360 degrees. So 360 degrees is 2 pi. So when we cut this like this, it will be 180 degrees, and this will be just pi. So 1 pi is equal to 180 degrees. 1 pi radian 1 pi radian. Please always don't ever forget to write radians here, rads, because there'll be a lot of confusion. You don't do that. 1 pi radian, 180 degrees. So it's basically like that. 180 degree, 1 pi radian. Yeah. So it is approximately 56 degrees and 16 minutes. And 1 radian is approximately 56 degrees, this much, and 1 degree is approximately 0.17 radian. How did we calculate that? So we know that 1 pi rad radian is equal to 180 degree, right? 180 degree. So we take this to the other side. So we take this to the other side, so we get pi rad is pi rad, one second, pi rad by 180 equals to 1 degree. So this is how we get 1 degree. Yes. Similarly, 180 by pi, we get 1 rad. How is that? Because 180 is not only 180, 180 degree is 180 degree into 1 degree, right? This can be also written as 180 degree into 1 degree. So if we take 180 that side, it'll be pi rad divided by 180 equals to 1 degree. And if we take pi this side, it'll be 180 divided by pi. So in both cases, we get this as our answer. So we've understood the concept really clearly. We should not have any problems in solving questions. Why did we take so much time in understanding the concept? It was because we wanted to solve the questions correctly, right? So this is the table that we can anytime just figure it out in our exams, because we've learned the concept very clearly. Many teachers tell us to mug this table up to remember it forever, but then we'll not do that. We can calculate this in our brains, right? If 1 pi is 180 degrees, we have visualized this. While drawing this, we have visualized it. So 180 degrees divided by 6 is 30 degrees. So pi divided by 6 radian, pi divided by 4 radian, pi divided by 2 radian is 90 degrees, pi divided by 3 radians is 60 degrees, pi is 180, 3 by 2 of a pi is 270, and 2 pi is 360. We will visualize this. So we will, we don't have to put an effort to remember. We will remember it. So this is a notational convention. So why do we use notational conventions? It is to make our calculations easier. It is to, aid us in our calculations, right? So that is why we use notational conventions. So since angles are measured either in degrees or in radians, we adopt the convention that whenever we write an angle degree, so I'll let the page, read itself.
Since angles are measured either in degrees or in radians, we adopt the convention that whenever we write angle theta degree, we mean the angle whose degree measure is theta, and whenever we write angle beta, we mean the angle whose radian measure is beta. Note that when an angle is expressed in radians, the word radian is frequently omitted. Thus, pi 180 and 45 4 is equal to degree are written with the understanding that pi and pi 4 are radian measures. Thus, we can
So now we were talking about how pi, you should write pi rads, right? But now we don't have to always write pi rads, they're telling. So yes, it is, omitted. And it's fine, right? We can still understand if you've understood the concept clearly. We don't have to write rads all the time. We can do without the rads too, right?
we can say that radian measure is equal to pi 180 times degree measure. Degree measure is equal to 180 pi times radian measure.
So what we learned from here, right? We'll have to read it again here. This is a really deep thing that they've told. This is kind of like a formula, but then we'll understand it. We'll never, memorize anything. So this is a radian measure equals to this is radian measure equals to pi by 180 into degree measure. So what is pi by 180? You remember what we were talking about right now? And what is 180 by pi? So 180 by pi is the ratio of, remember, 180 by pi is the ratio of 1 radian. It's the ratio of 1 radian. So, whenever we have any degree measure, so it'll be 1 radian into the degree measure. You get me? So we can get the radian measure from there. Pi by 180 is 1 degree measure, right? Pi by 180 is, 1 degree is pi by 180 radian, right? So pi by 180 radian into degree measure. How is that possible? Huh. Okay, I'll give you an example. So let's say, you have three chocolates, right? A radian measure, right? Let's say you have three chocolates. No, let's say you have a packet. One packet, one packet in which you have three chocolates. Three chocolates, right? Like this. You have one chocolate, two chocolate, three chocolate. So, we are converting packets into chocolates. So how do we do that? So one packet has three chocolates. One packet equals to three chocolates. So let's say you have some friend of yours says that you have seven chocolates, right? Seven chocolates. So how many packets will that be? To understand that, you will have to divide it by 3, right? Have to divide that by 3. That is, what is 3? 3 is one packet. But then you'll have to divide it in by 3 chocolates, because division and ratios always happen in the same unit, right? One packet is always 3 chocolates. So you're dividing 7 chocolates by one packet. But you cannot divide 7 chocolates by one packet, right? Because they are different units. Chocolate and packets are different units, right? So you divide 7 chocolates by 3 chocolates. You convert this different unit into the same unit. You convert this different unit into the same unit, which is into chocolates. You convert the packet into chocolate, right? So what do you get? You get two. Two choc two chocolate, sorry, you get two packets and one chocolate left, right? So it's basically like that, right? We cannot convert it into a different unit. So that is why we are doing like this. So this is basically radian measure divided by degree measure. But then we cannot divide the degree measure because they are in different measures. So we multiply it, right? So one radian measure is equal to, okay, I'll explain this to you. So one radian measure is equal to 180 pi by 180, right? 1 degree radian measure is pi by 180 by pi. One radian measure is 180 by pi. So it will be, what did we do here? So 180 by pi is degrees. 180 by pi is degrees. This is 180 by pi degrees. 180 by pi degrees. Here you can see the degree symbol, right? Here it is degrees and here it is radian. So we are changing it into the same unit. If you've understood the chocolate wala example correctly, right? Please watch the video again if you've not understood the chocolate wala example. If you've understood the chocolate wala example, you need no further explanation, right? I'll give this as a homework. How the chocolate wala example can be converted to this, right? I'll give no further explanation. If you have any doubts, please ask your teacher, right? Please ask any adult. Please ask anybody. Please, talk to your friends. Tell them about the chocolate wala example. Tell them about how it is related. Because I want you to just not listen. I want you to understand. I want you to connect maths to, your real life. Yes. So yes, I'll take your leave now. This is like a very basic thing. So surely with that chocolate wala example, I want you to, use your problem solving skills and not only understanding skills. So yes, I'll take your leave now. Bye. Just kidding, just kidding, just kidding. How could I leave you, huh? Like that? How could I leave you? I'll show you right now. Okay, so one rad is one rad is 1 by 180 by pi degrees, right? 180 by pi degrees. 1 rad is 180 by pi degrees. So when we take the degree measure, so what do we do with radians? So what we do is we take the degree measure. So what do we have to do here? Like the chocolates, let's say we have seven chocolates, right? We in the previous one we had 7 chocolates. So let's say here we have x degrees, right? X degrees. So we have to divide that with divide that with 180 180 degree by pi. So then what do we get? Pi by 180 pi by 180. What we get is pi by 180 into x degrees. So what did we get here? Pi by 180 into x degrees. And what did we get here? Pi by 180 into degree measure. So similarly, for degree measure also we do the same thing. I'll explain the chocolate wala example again for more clearer understanding. So what we have is, one second, we'll erase all of this. So what we have is 1 degree, right? What we have is one packet. We have 3 chocolates, right? One packet, 3 chocolates. So let's say you have 7 chocolates. How many packets of chocolates you have? You want to know how many packets? How many packets in 7 chocolates? You want to know. How will you know? You will have to divide 7. You'll have to divide 7 chocolates by one packet, right? To divide 7 chocolates by one packet. But you cannot divide it by one packet because C and P are different units. You cannot divide in different units, right? So what do? You divide in same units. You divide C divided by 3 chocolates. So you get the answer as 2. 2 packets, 1 chocolate. You get the answer. So this is the answer. Done. Your answer is done, right? Simple. Simple as that. So listen to this part again. I'd suggest you to listen to the part again. I explained it really slowly at the end. So if you would listen to it again, it will make more sense. And then these examples will be, die haath ka khel for you. Let's solve the fifth example, because why now? Why not? It'll be easy only. The arcs of the same length in 2 circles subtend angles at 65 and 100 degree at the center. What is the ratio of their radii? So the arcs of the same length. So they have the same length, but then their radius should be different, right? Because if the arcs are of the same length and the angles are different, so then their radius should be different. Don't look at the answer, okay? So what will be the answer? Calculate, and I'll also show my screen what I've calculated on paper. I'll show that. So this is the calculation. First we convert degrees into radians like this by multiplying it by pi by 80, that ratio, like this. And then as the arc lengths are the same for the angles, so r1 into theta 1 equals to r2 into theta 2. So that will always be the same, right? So likewise we do the further calculation and we get the answer as 22 by 13. So after we've understood all of the theory part, the calculation was really quick. I'm like very happy with the experiment. So yes, let's move on then.